Hi, this is Paul. We are doing Leetcode must-know interview questions. Today's challenge is merge two sorted lists. These are linked lists. We are in the linked list section right now of the Leetcode challenges, and there's several more. This is the last one that's rated easy. The rest of them are medium. I think one of them is hard. But the challenge for today is you are given the heads of two sorted linked lists. List 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. And there are some examples here. Here's an example with a graphic. We've got a list 1, 2, 4. We've got a list 1, 3, 4. If we merge those in sorted order, we get 1, 1, 2, 3, 4, 4. It doesn't seem to matter if there's a tie which node goes in first. On the 1s, it looks like the bottom row is going in first. On the 4s, it looks like the top row is going in first. I suppose whatever algorithm you choose, we'll put them in a consistent way, but it doesn't matter. You see something like this. Input list 1, list 2. Looks like an empty array. You can write solutions in Leetcode in a number of different languages. Different languages have different conventions. I write these solutions in Java, and in Java, an empty list is null, and end of list pointer is null. So we'll think of this as being null. Constraints number of nodes is in the list is in the range 0 to 50, right? So that's what this would be here. At least one of the input lists could be null. Okay, I just realized we can't really see the method signature here. So we can pull this over. There it is, merge two lists, and we have two lists coming in, list 1, list 2. Here's the definition for the list node. It's got an integer value. It's got a pointer to the next node. It's got a constructor. The constructor has two optional parameters. If you just call the constructor, the value will default to 0. The next pointer will default to null. I don't know why, that seems to sort of be in violation of the spirit of the problem. I don't think you really want to call the node constructors. It says make the list by splicing together the nodes of the first two lists, not by creating new nodes and linking them together. So in any case, we're not going to create new nodes and link them together. Linked list, a lot of linked list problems lend themselves to recursive solutions. The last problem that we did, the add two numbers, we did with a recursive solution. Because in that case, they provided a constructor where it actually, made sense. I mean, the only reason for having it seems like to do a recursive solution. So we did a recursive solution. We did a recursive solution here, although we're not going to use these constructors like this. But let me pull this up a little bit. I guess that's as far as it goes. All right, the code looks like for something like this. It's possible that it's possible at any time, even on the first call to the method, that one or both of these lists is going to be null. So we can say if list 1 equals null, then we'll just return list 2. Talk about why we would do that in a second. And actually, why don't I just copy this? If list 2 equals null, then we'll return list 1. So if a list comes in and it's null, there may be nodes left in the other list, but all we need to do at that point is to just merge the remaining nodes into the list that we're going to return as a result. So if we run out of nodes in one list, we'll just return the other list. And again, we're doing this recursively, so that may make more sense after you see it. But let's create a node that we can use as a starting point, like this. We're not calling a constructor on it. We're just giving it a type. And let's say if list1 dot val is less than list2 dot val, then the head will equal the list1 node, and the next pointer will point to the result of merging the rest of L1 with L2. So merge two lists. We'll pass in list1 dot next, and we'll pass in list2. Okay. Else. Okay, the alternative here for list1 dot val greater than or equal to list2 dot val would be set head to list2, and next we would merge list1 with list2 dot next, and return the head of the list. Okay. So actually, as I'm looking at this, these two are so similar that it occurs to me that we might be able to simplify this. So if we declare that list node, the head node, and then, for example, in the if statement, point it to list1, and then point the next pointer, head.next, I mean, that's really pointing list1.next. So if we did this and just said list1.next, it's the same thing, isn't it? We could get rid of that. In this case, same thing, but we're pointing head to list2 and then changing the next pointer. And we could do that. We did that. We're not returning the head node anymore, because we'll just return list1. I mean, it's the same thing. We pointed the head node to either list1 or list2. And once we finish with this, we can return it. Okay, get rid of that. Get rid of that. And let's try running it. Wrong answer. Oh, found cycle in the list node. Uh-oh. Oh, I see it. I thought I fixed this. Okay, we take that off and just paste it here. It's got to be list2.next. All right, run that. All right. Good. Good, good, good. Move this over. This over. Where can I grab it? Let's go ahead and submit. Just happened there. I didn't think it would show up in there. Hold on. Oh, that's weird. No, it usually shows up over here. Runtime. Oh, gee, not very good. Recursion hurts the speed, maybe. Is there a memory solution here? What is it? What are all those colors there? Memory. Oh, memory. Well, okay. Anyway, that is it. I thought that was going to be a nice, tight solution, but not so great on the time. I can't even believe it. I'm going to submit it again. Oh, okay. Well, that's better. Now we're getting somewhere. Okay. Better than 95, better than 95%. Okay. All right. Hope you enjoyed the video. Please feel free to like, subscribe, comment, and see you next time.